Hi fellas, I got another CRT TV to repair, so here it is. This time it's TV without decal. It was there, but I lost it. Anyway, it's probably in my car. Anyway, I'm gonna show what this TV is to you later. Problem does not turn on again. Similar stuff. Clients, I should say, they said that it died during or after thunder, so probably problems in power supply. When I switch it on first time, this time you see and hear nothing, alright? But first time I turned it on, when I hit the switch I heard sound like when I whack a picture tube a little bit. That is nothing else than a degauss coil getting power through a PTC. So large surge making through, then PTC warms up and limits current. But when that surge is flowing through a coil, it creates physical movement, which whacks a picture tube a little bit and you hear that sound. So that must mean that fuse is okay, because fuse is located before the gauss coil and power supply itself. So if power supply didn't blow the fuse, it's alright. It's better scenario usually, and since it shouldn't, I hope ain't gonna involve much catastrophe inside, but hell knows, we'll see. Anyway, let me pop the cover off and we will see. Alright, so I found TV model. It's Thomson 20DG16KH. I took the cover off. Inside it looks like this. Dusty, as always. First glance at the board. Lots and lots of dust. Tiny flyback. And actually that's because, partially, or clearly because the picture tube is small. It's not a 21-inch TV that I usually have a deal with. So, first glance, nothing is really dark, nothing is charred, so probably problem is in capacitors somewhere, or little diodes. At least I don't see catastrophe inside. That's good anytime. That's good anyhow. So I'm gonna clean it, investigate, and I'll come back later. So I did some investigation in power supply section here, because I ain't getting any signs of life. I tested fuse, it was okay, as I mentioned before. And I also now know, since I got a nice shock, that power is making its way through to this capacitor, which smoothes rectified mains. So I did some investigation, basically checked some diodes on rectifiers, basically stuff like that. Checked the switch transistor, it was okay. I'm gonna check some capacitors, but I want to show you few interesting things. I got my meter in diode / continuity testing mode, and let me show you a few diodes here. Well, this diode you can see is reading like 97 millivolts. Okay, it is in circuit, correct. I'm gonna pull one leg off and take a reading, but let me show you another diode here. This glass passivated stuff. Okay, so I got it connected and nothing in both directions, so this diode is definitely dead. Looks like regular 1N4148. So and it is marked like diode, not like Zener. Here you can see like this guy, it's a Zener diode. This one is not. So I'm gonna change it, check few caps as well, and we will see what will happen. Alright, I flipped the board to pull out those two diodes, and let me show you what I found. Look at these transistors in SOT23 packages. As you can see, transistor in the center of the screen now is busted. So is this guy. That one looks it one piece. That one is still in one piece, so probably okay, but I'm gonna test it anyway. That kinda sucks because I don't know what those transistors are, but they are near the optocoupler, so they must be some generic general purpose transistors. So one of those three-leg devices might also be TL431, because I didn't find any voltage reference on this side of the board. There is no Zeners here, so must be on this side. Looks like this guy is voltage reference, since it's connected directly to this optocoupler. But anyway, I'm gonna do further investigation, and we will see again, hopefully. So I pulled these two diodes out. This is the one that showed weird value of about 70 millivolts. I pulled it out and it actually reading in both directions, which is mwah. However, it may be not a simple diode. However, again, I checked a datasheet, and EGP10J is just a 1 amp ultra fast recovery rectifier. So basically a fast diode for switch mode power supplies and other speedy applications. While this guy seems to be I hope you can make it out, but I'm not sure. Can barely see. 4148. It's a 4148. I have 100 of this, so no problem. And this I would replace with UF4007, which is ultra fast recovery rectifier, 1 amp rated 2. I'm gonna check some capacitors, I'm gonna probably put it back together, and then I will show you the result. However, I don't know yet. Maybe some interesting will come across and I will show you guys, but if nothing interesting comes across, I will just show you walking TV, hopefully. So, first of all, excuse me for this crude screen capture, but because I'm way too lazy to install special software like Camtasia Studio or blah blah blah. So, the components you saw on the board which exploded was TP54, which is BC846B, and TP58, which is this transistor, which is actually nothing else than an NPN transistor with built-in bias resistors. Both of these two guys is 22K. I actually found a datasheet for it. BCR141 NPN silicon digital transistor. I don't quite understand why they call it digital. I do understand though that they basically used in digital circuits, but Is it correct to call it digital that way? I don't know. Anyway, intended for switching circuit inverter interface, stuff like that. So you can see from the statement, built-in bias resistors, 22K each, schematic in and pin out, base, collector, emitter. Pretty generic actually. So yeah, I can even mock up one myself by little bit of modification to the board. Anyway, that's I need to change this transistor and this transistor and this diode and this transistor, excuse me. So this diode blue and this transistor blue, so this transistor may be bad as well, so I'm gonna check all over here as well as resistance values. Alright, so I did change a few resistors here and I did clean up, so you can see the board is not contaminated very much by flux residue, so I can show you guys. I did replace all three of these transistors. I replaced them all with, I believe it's 3904. So, as you remember, TP58 was digital transistor. And that's basically nothing else than just a regular NPN transistor with few resistors connected inside. There was 22K from base to emitter, and there was 22K, one into base, one into floats, and that's where you connect it to your circuit. So what I did, as you can see, from base, here's track, it goes to this 0402 resistor and goes to emitter. And this resistor is 2.2K, so by adding another 22K here, I won't change situation much, so I just left it as is with this base to emitter resistor. But that other resistor inside that just one end floats was like a base current limiting resistors. So here you can see another resistor here going to the base straight. That was 10K plus 22K inside, so I did change that 10K resistor to 33K, because here was 10, there was 22, 32, 33, close enough. I checked all the resistors here, all seem fine. So I say let's take it together and we will see, will this baby fire up or not.